Hey class, so today we're going to be looking at financial math for the solver for future value. Now the only thing that's a little bit different is, so we're going to be still looking at compound interest. Typically sometimes we do the TVM solver, but these are really old technology that we're kind of moving away from, and we're still in the process of finding an app that works the best with you guys. So what we're actually going to do today is we're just going to be focusing on using the compound interest formula, okay, to solve the following problem. So essentially it's just a day 2 of compound interest, I would say. I'm just going to work through a couple of problems with you guys, because compound interest is the harder interest to understand just because there's more elements to it. So we have the total amount of interest earned, okay, based off the following formulas. And then we also have if you want to solve for the principal amount based on what you want in a future, okay? And just a little reminder that I equals R divided by N, and little n equals the number of time by the years, okay? So when we're going and we're solving this stuff. So if you ever see this, we're not really going to be worried about that information there. Again, we're moving away from that concept, and it's better that you have the skills to practice it actually solving. So let's take a look at a question here together. So Barbara invested $2,500 at 6% compounded semi-annually, okay, for 4 years. How much did she have in total at the end of the investment? Okay, so again, we're not focused on this. Okay, so what they want to know is, what did she end up with at the end of the year? So we know that we're going to be looking at the accumulated amount. So A equals P, okay, 1 plus I to the power of N. Okay. So let's just talk about what is our principal. So our principal in this equation was the initial value of $2,500. Okay. The interest, we have to do a little math, so we have to put that into 0.06, right? So we have to put that into a decimal. And then because it's compounded semi-annually means twice a year, we would divide it by that, and we get a value of 0.03. Our N, okay, is going to be 4 years, but again, compounded semi-annually, so we multiply. Okay. And we get a value of 8. Now all we have to do is we have to plug those values into our formula that we already identified that we're going to use. So we go A equals 2,500, 1 plus 0.03, all to the exponent of 8. So again, when you're going about solving this, solve the inside, then to the exponent, then multiply by the beginning. Okay. So in the end, when we do this full question out, we find out that the total investment after 4 years is $3,166.93. Okay, let's take another look at another question. Okay. Again, it's another question trying to solve for essentially the future value. So what I would like you to do is I would like you to pause the video here and try this question by yourself. Again, it's the same idea. It's A equals P, 1 plus I to the power of N. You're solving for A. Okay, so you should have tried that question yourself. Let's talk about the elements of this question. So the principal, the initial amount deposited was $3,600. The interest rate, okay, so the I is going to equal the interest rate, which is 0.048, right? And it's divided by quarterly, so it's divided by 4. We get a value of 0.012. And then the N value is, again, it's 6 years, but this time, again, it's quarterly, so times 4 equals 24. Now what we would do is we would plug that into our formula, that information. So I'm just going to move over here. So we get A equals 3,600, 1 plus 0.012 to the exponent of 24. Again, when we go about solving this, add, then to the exponent of 24, then multiply that. Okay? So when we do that, we get a value of $4,793.30. Because remember, money has 2 decimal places. So just a little reminder there as we get going. Okay, let's take a look at 2 questions that are not solving for the future value. Let's look for 2 questions that are solving for the present value. Okay. So example, Doreen invests $9,800 at 6.35% per year compounded semi-annually. After how many years will she have enough to purchase a motorcycle of $14,000? Okay. Okay guys, so this question will be a little bit more challenging because it's actually asking us to solve for time, but it's more just about rearranging the formula to solve. But I would say this is the harder end of the question. So I'm just going to write out the basic formula, and then we're going to talk about what we have. Okay, so let's look at what we have. We know that the principal value is 9,800. And we know that in the end, Doreen wants 14,000. We know that the interest rate, we have that, is 0.00635 because I just converted it, right? So just by dividing by 100. And it's compounded semi-annually, so that's why we divide it by 2. And we get a value of 0.03175. But our n is really our unknown. But whatever the n is, okay, it was multiplied by 2. Okay. So let's plug in and let's solve. And this is going to bring up some older concepts that we've gone over. So we have 1,400 is equal to the initial value, 1 plus that interest rate that we solved for, to the exponent of our unknown. So we're going to just start by solving the first little part. So we can add this, but we can divide out 9,800 to the other side. Okay. Which leaves us with a value of 1.43. And then we're left with 1.03175 to the exponent of n. Now, if you recall, this is why the exponent unit is so important to this unit, is because if you recall, log can bring down any exponent. So we would go log 1.43 equals n log 1.03175. So it brought down that exponent for us. Now to solve for n, all we do is we move log 1.03175 to the other side by dividing. And that would cross out, and we would find out that n equals 11.44. Okay, but we're not quite done, because if you remember back to here, we said whatever log was, it was multiplied by 2 initially. So what we have to make sure we do is we divide it by 2. Okay, and 11.44 divided by 2 gives us a value of about 5.72 years. Okay, so that's a more difficult question, because what it's asking us to do is to solve for time. So it's asking us to really delve deep. Typically, I wouldn't give you that hard of a question, but it is good to practice something like that. Typically, I'm going to be looking at solving for the future value or anything else. But let's try your own, let you try another version of that question. So the next question is very similar to that, so I'd like you to take a minute to try it yourself. Okay guys, let's take up the last question together here. So Jacob invested $3,500 that pays 8% per year comment. How long will it take for his investment to double? So again, you're just going to use the basic formula. So A equals P, okay, 1 plus I, the power of N. Let's talk about what we have. So we have, essentially we have what he wants in the end. So you would double 3,500. So he really wants $7,000 in the end. His principal right now, so what he has right now that he invested is 3,500. Okay. His interest rate is 0.08, and it was compounded monthly, so divide it by 12. You get a value of 0. We're going to give it 2 decimal places, so 2 values in the decimal places, that's what I mean. So 6.7, and then we're going to try to find his n again. Okay, and remember, whatever his n was, it was multiplied by 12, so we'll do the opposite of that in the end. Okay. So I'm just going to solve just below here. Okay. So we would go $7,000 equals P, equals $3,500. Okay. 1 plus 0.0067 to the exponent of n. Okay. Divide $3,500 to the other side, and we get a value of 2 equals 1.0067 to the power of n. Now again, we're solving for an exponent here. So in order to solve for an exponent, we're going to use log. So we go log 2, brings down an exponent of 1 in front there, and then we would go log 1.0067, and that forces the exponent of n to come down in front. So now essentially these two terms are multiplying by each other. So we're going to divide log 1.0067 to the other side of the equation, crossing it out. When we do that, we get log 2 divided by log 1.0067. We get a value of 103.8 equals n. But remember, this is where I talk about that here and here. So because this value essentially was multiplied by 12, in order to find out what the actual time frame is, we're going to divide it by 12 now. And we find out after dividing it by 12, okay, that we get a value of about 8.65. So 8.65 years is how long it would take for Jacob's investment to double. Okay guys, so that's the end of today's lesson. So again, it's just more compound interest. Tomorrow I'm going to be going on a little bit deeper into some of this as well. Your homework is page 44, numbers 1 to 3, 7 to 8. So it's only 5 questions to try, so have a go at them.